A Swiss research institute and an English university are working to develop a specialty drone that could analyze fires at close range and relay the information to firefighters. The drone, dubbed FireDrone, comes from researchers at Empa and Imperial College London and is an experimental quadcopter made of temperature-resistant materials. It is designed to provide initial data from the hotspot, which would allow firefighters to create an optimal strategy before going into the fire. Existing drones can already capture aerial photos, lift fire hoses onto buildings, and drop extinguishing agents. But if these conventional drones flew too close to the blaze, the heat from the fire would melt its frame and the electronics would fail. David Häusermann, who works at Empa's Sustainability Robotics lab, collaborated with firefighters to find a material that could protect a drone's batteries, motors, sensors, and electronics. He also received help from colleagues at Empa's Building Energy Materials and Components lab, who synthesized an insulating material that made the drone more fire resistant. The material is an aerogel and consists of almost exclusively air-filled pores surrounded by a hint of a polymer substance. The aerogel chosen by the researchers is based on polyimide plastic, which NASA is also researching for the installation of spacesuits. However, the researchers' composite material also consists of silica and is reinforced with glass fibers. The inspiration for the material stemmed from animals that live in extreme temperatures, such as the Arctic foxes and penguins. These animals possess corresponding layers of fur and fat that enable survival in their environments. To test FireDrone, the team lit a gas fire in an oversized metal bowl and steered the drone into the flames. Empa reported that the prototype and its thermal imaging camera, electronics, and carbon dioxide sensors survived several test flights. Empa said it is engaging in discussions with potential industry partners to develop the prototype further. I'm Nolan Beilstein, and this is Manufacturing Now.